Hello, and welcome to the 2020 August Live with Nassim session. I know we have inquisitive minds and explorers of thought from all around the world, and we are so excited that you have joined us for this awesome opportunity to get to sit down with Nassim and push the envelope in the understanding of ourselves and our world through the lens of a unified vision of science. And for contributing members, the opportunity to get to ask questions directly to Nassim about the latest advancements in unified physics, type 2 civilization technology, and all the other fascinating topics that his vast repertoire of knowledge can lend insight to. I know Nassim and Dr. Alderiel, the physicist, have been working extensively on some key breakthroughs that are going to not only help us better understand the fundamental physics of the universe, but also to allow us to see the connected universe in a whole new way. And I know I'm very excited to get to learn more about these advancements, these latest developments as they become available. And I think this is just a great opportunity for us all to get to see the universe in a whole new way. So for the contributing members in the Q&A, you can post questions. And we've also implemented somewhat of a new method to select for the questions that the community is most interested in hearing, because there's so many questions and they're all excellent. And you know, if we had all day, we could get through them all, but unfortunately, you know, we've got a short amount of time. So we have the opportunity to upvote questions. So if you see a question in the Q&A that you'd really like to hear addressed, you can vote on it, and we can filter the questions, so to speak, via their popularity. It's kind of a democratic way to select questions that the most people want to hear about, so that you know, we can really get what questions are most prominent on our on your mind. So Nassim, is there any recent developments, anything you'd like to share with the group before we get started on some of the questions? I think your microphone's on mute right now, but.
Yes, thank you. Thank you, William, for introducing this event. It's great to be here with you guys. We have some supporting staff as well on the call. I think we have David and Penny. Are they still on there? I just wanted to ask if we're gonna highlight the people that are asking questions, so that we get to interact a little bit with people. That's always fun. I'm always excited about these talks because it's great to share with the public. And yeah, I've got a lot going on right now. We are working in the laboratory on certain technologies that are very exciting. And as well, of course, I'm working on this paper that unify physics, that does the final job on unifying physics, utilizing the holographic mass solution. And every time I turn the corner on this thing, it amazes me. This fundamental ratio that I identified in the holographic mass and quantum gravity and holographic mass paper in 2012. And actually, I identified it in 2011, but you know, it took a while to publish. And it really is a fundamental invariant relationship in the universe. That is, the universe doesn't really do mathematics, of course. It does, you know, ratios, relationships, you know, relationship of forces, relationships of size, density, you know, and a relationship of wave uh, forms, phase relationships, you know, phase angle, and so on. And so, what's happening with this paper is that as we're writing this, as we discovered this unifying ratio, this unifying relationship of volume to surface ratio, um, from the Planck scale or even the sub-Planckian scale to the universal scale, is that these relationships become more and more obvious in terms of, for instance, the relationship of the four fundamental forces and how they interact at each scales, and the relationship of densities, the relationship of electromagnetic fields, and all this. And all this, these relationships, when you examine them at different scales, all of a sudden output the forces, it outputs the fundamental constants we see, like alpha, for instance, or the Reinberg constant, or the G factor, and of course, the gravitational constant. So for the first time, for instance, in history, we're able to from a theoretical base, account for the gravitational constant with some 10-digit accuracy, which is remarkable because G, or the gravitational constant, in our equations is very problematic because it's only known with some accuracy, and even that's debated, with 5-digit accuracy from experiment. So
the precision's too small for the precision level that you're working with.
exactly. And it's a problem because in the holographic mass solution, G is involved in all the Planck units. G is involved. So it drops the resolution, right? It drops the accuracy to 5-digit digit accuracy on all the equations that G is involved in. So since, you know, in quantum theory, we have measurements that are known with 13-digit accuracy, like the G factor, or you know, the Reinberg constant with 12-digit or 11-digit accuracy, and so on, which is a level of accuracy we deal with in the quantum world when you try to incorporate, you know, when you're describing the quantum world with, you know, this fundamental pixelation of space-time, which utilizes the Planck units, you are limited to a 5-digit accuracy, right? To 5 significant numbers accuracy because of G. And it was definitely good enough to predict the radius of the proton, which was actually, you know, much worse. It had 4% inaccuracy when I predicted the radius. I found out that actually the standard model radius was 4% off, and that was the prediction I did in 2012. That got confirmed, and now it's been rectified, and the co-data value is the prediction I did. But more importantly, when we applied the equation at the deep level of particle physics in quantum theory, you know, and to the fundamental constants, like the Reinberg constant, like alpha, and so on, you know, we were limited. We had this problem that G was limiting us because we were using Planck oscillators, you know, what I called the spherical Planck unit, right? So we were using PSUs, and that's what's amazing in this paper is that even with that, we were able to like figure out this ratio, volume to surface ratio, and apply it to all the scales. And as we applied it in all the scales, and as we, you know, manipulated the various equations to output, and it was outputting, you know, certain constants, we were able to back engineer from the data it was giving us what G should be. And so we were able to back engineer G out of these fundamental ratios and get G with, you know, 11 to 12 number accuracy. And we know it's accurate because when we apply that G, right, to, of course, the first 5 are the same than the measurements, and then, but we have all these other numbers. So how do you verify that these other numbers are right? Well, you know, you take that G and you put it in the equations, and then you output constants that we measure very precisely, and it outputs all the right numbers, right? Not just for one constant, not just for one particle, but for all of them, right? For particle mass, radiuses, for instance, the electron is well known, and so on. And it outputs all the right things, the Reinberg constants, all the G factor. And so we know our G now is absolutely accurate, right? And that's really, like, that right there is remarkable. But the fact that now you take all these constants and you take all these equations and you have 12 to 14, in some cases we have 14-digit accuracy, in some cases we're exact, meaning we don't know how far the accuracy is, but because of the relationship we know we're exact. We have this template, right, from which you can, so now you go from the Planck scale, right, with, now the Planck scale is known to, you know, 10 to 12 digit accuracy with the new G. And now, you know, you go from the Planck scale all the way back up to the universe. And now you have huge accuracy on like cosmological things, like the background temperature of the universe, the acceleration, the size of the universe. Like all of a sudden, everything is upgraded, where usually in in astrophysics, right, or in astronomy, but in astrophysics, I mean, basically, if you're in the same order of magnitude, you call it good, right? Right? I mean, if you're, you know, within 1 0 at, you know, at 1 order of magnitude, which is huge, you know, an order of magnitude can, you know, can half the size of the universe, right? So, you know, but it's that type of thing that that all of a sudden just goes away, because you get, so because you have this level of accuracy at the quantum scale, right now, and those equations all of a sudden are able to give you information about the universe, right? Because now it's unified, so it's all the same equations. Now, when you apply it to the universe, now you have that level of accuracy for universal events. So that is like remarkable. It's unbelievable. Never mind that we, as a result, although we unified everything, now we have things that are like more decorrelated, meaning that it used to be that in order to know the radius of something, you needed to know the mass, right? In order to know the mass of something, you needed to know the radius. But with these equations, now you can just output it directly because the relationships are known. So for instance, you can look at the proton and output the mass of the universe, or output the radius of the universe. As long as you have one part of the scale, you have all the other scales. and the radius and the mass are can be independently found without knowing anything about that scale. So you can look at the proton and go, oh, okay, the radius of the universe is that much, and the mass of the universe is that much. And so although you know nothing about the universe, with these equations, you just apply it to the proton and you know the rest. You can figure out the electron, you can figure out galaxies size, average size of galaxies, you can figure out, you know, average size of stars, things like that. And so it really is a whole new way of thinking about physics, where it's unifying, but literally unifying, meaning like from any scales, you can figure out any other scales because the relationship are invariant. They're always the same. And so it's really amazing.
So almost anything we know, it's always a relationship. We know one thing, how it relates to another. And that's almost like a definition for information itself. What's the relationship?
Mm-hmm.
And so it's really remarkable that phi relationship, that relationship you discovered in the quantum gravity and the holographic mass solution,
Mm-hmm.
that ratio is almost the key to understanding these relationships across the scales, from the Planck scale to the cosmological scale.
Exactly. And it, you know, initially we weren't sure how to do it. And with, more and more we write these equations, and more, it just always come back to that fundamental phi. And I want to clarify, this is not the golden mean phi. This is the phi I identified in the, you know, phi in physics is commonly used to describe a ratio, a relationship. And that's why it's used for the golden mean, which is a ratio, right? Like the Fibonacci series. And so, you know, but in physics, it can be used for any ratio you're trying to identify or you identify. So I used phi in my paper. So that's the letter we use to describe it. But yes, it's a surface to volume ratio that describe the information transfer, as you were saying, that's occurring between the inside of a system and the outside of a system. And all these things I'm talking about might sound, yeah, like, you know, somebody's writing Russian dolls. Yeah, like Russian dolls. Yeah. And the relationship of the smaller doll inside the bigger one, except they're Russian spheres, right? So I don't know, they're not Russian, they're universal spheres. But you know, you could think of it as this thing that's like moving like from one scale to the other, right? But that maintains a relationship so that you can think of it this way, so that if I made the pixel size, right? If you went from, you know, let's say you went from one scale to another, right? And the first scale that you're doing with the lower scale. So the Planck to the proton to the electron, right? Then you would do, so for, let's say for the proton, you're using the Planck as a spherical Planck unit, like as a PSU, for your pixel size to get the ratio, right? Then if you went from the proton to the electron, you could use the proton as your pixel size to get the electron, and so on. You could scale like that, and the ratio would always be the same, basically.
But your level of precision is at the Planck level of precision.
That's right, exactly.
Amazing.
Which now we have to very high degree because of this new G, right? So we are, you know, so we're in the middle of finishing all this, but you can imagine that, you know, it does the job in such a way that um, it becomes this amazing um, puzzle that comes together. All the pieces come together in such a way. It's fairly complex because there's so much in physics, right? You have all these constants, you have all these particles, you have larger scale universe, all this stuff. But it comes together in such a way that is so beautiful and so precise that, you know, you can't, what's crazy about it is that more you write the math and more you write the physics, more you see the pattern, and more you see the pattern, more you see that you can't move anything in the framework, meaning everything becomes super defined, right? So that you realize, like, you know, on the 11th number after the period, right, on this constant, if you budge this number by 1, right, like instead of a 5 it becomes a 6, for instance, right, then everything else in the whole thing like goes wrong. So you don't have margins, like everything becomes like rock solid, right? Like it's defined to like the nth degree precision, right? It's tuned very, very precisely to produce our world.
Well,
And,
that's called the fine-tuning problem, even.
right,
Yeah.
exactly. You can see the tuning. You can see how well defined, you know, the universe is, and you can see that like it cannot be like, it's because now you see the relationship. Now you see, you know, that that it's one thing, right? It's not like you have 4 forces. It's not like you have, you know, 20 different constants. And that all these things are unrelated, which is currently the case in physics. Like many of the things are not related. Some of them are, but you know, we don't see a relationship in standard physics between, for instance, the weak force, right, and the strong force, or the weak force and the gravitational force. You know, we don't see her, but in these equations, you see those relationships. You see how they depend on each other. You see that and you see that the precision of them, right, that, you know, defines, you know, how everything is working. And so then you see the oneness of the thing, and it just blows your mind. It just blows your mind.
Well, it just seems to me like that's been the goal for unified physics, going back to Einstein. Even Paul Dirac, was, you know, amazing physicist, was working on that one ratio that would tie it all together.
Right.
It seems like
Dirac actually identified that ratio, and he was very, very close. He had it loosely because he didn't have a fundamental mechanics. You know, he didn't have a mechanism to describe where that ratio was. He just noticed it in physics. He noticed that there was a ratio of approximately 10 to the 20th that just kept on flying around everywhere, like the relationship between the strong force and gravity, the relationship between the radius of the proton and the radius of the universe, the relation, like he noticed like this 10 to the 20 was floating around, and he said, this has got to be something. Like this can't just be a coincidence, right? It just keeps popping up everywhere. And he called it the large number hypothesis. And it was at the end of his life that he started to talk about it publicly. And he was accused of doing numerology. This is one of the best mathematical physicists the world has ever seen. Most people will consider Dirac, Paul Dirac, many physicists will say that he was at least at the level of Einstein. Many physicists will say he was a better physicist than Einstein. You know, he solved some of the hardest equations in physics. He was you know, sitting in the seat. He had, you know, the position that Newton had at Oxford. And so, I mean, it really is remarkable that at the end of his life, when actually he was so close, but he didn't, and they told him he was doing numerology. Well, it's remarkable. But basically, you know, he just didn't have the mechanism where this number was coming from. So it looked like numerology to physicists, because it was like, okay, yeah, but like, yeah, that number is there, but it's got to be a coincidence, because you're not giving us the mechanics of how this number why is there. Like, it was hard at the time, and it's getting easier, but still hard for physicists to think that somehow the proton is related to the universe. You know, somehow the size of the proton is related to the size of the universe. It's hard for them to think that way, although if you think about it for a minute, the two are like the proton is inside the universe, and it's oscillating, and the universe is oscillating. So it's not so far-fetched to think that there's some kind of harmonic relationship between these scales. I know they're hugely apart, but the universe is full of protons, and they're all oscillating, and they all emerge from a timeline that goes to singularity, that goes to zero, when they were all unified, right? So it's like, clearly there's a relationship. It's not far-fetched to think of it as a relationship, and now we're seeing it, which is remarkable. You know, it's and I'm so proud of Dirac for having, you know, there's interviews you can find on the internet of Paul Dirac talking about the large number hypothesis, and in his case, you know, he thought it had to do with the variance of G. Actually, he thought that it had to do with the variance of the relationship of gravity in the universe. And what we show is that that was really close, but the variance is in the density of the vacuum. The variance is in the density of the fluctuation in space, which produced G. So it's actually, he was very, very, very close. He was just missing the mechanism.
The variance.
Yeah.
Where's the variance?
Meaning that when the universe grew, the vacuum density dropped, right? But you know, so the relationships were generated by this change, right? So and this is what the equation shows, right? That's why we end up with dark energy at the cosmological level, where the vacuum density is like 10 to the minus 30 per centimeter cube, right? 10 to the minus 30 grams per centimeter cube. And at the quantum level, it's 10 to the 94 grams per centimeter cube. There's a 120 orders of magnitude difference in density. That is because of this. So Dirac was really, really close, but because he didn't have the mechanism, he assumed a variance in G, where in fact is a variance in the vacuum structure. So, so it's really interesting that it took all this time. I think if they would have listened to Dirac and not assumed that he had lost his mind, and I think it could have been found much earlier, but everything is on perfect timing. And, you know, now we can really unify physics and really help humanity go to the next level, you know, because when you start to see the physics of the world this way, you really kind of get a sense that the universe is you, meaning you feel this relationship very profoundly. You know, you don't just, you know, all of a sudden you're you're not just in the universe, you're part of the mechanics of the universe, right? And so now you start to realize, and you just apply the equation to yourself, you know, and you start to realize your biology, your physics, and all this is just an information exchange with the field. And that exchange is actually what transforms our reality, meaning our reality is part of this constant information network that's learning about itself, and you're part of this. So all of a sudden, you feel less isolated and part of a larger, you know, and you see it in the equation. So it gets out of like being a dogma, and it becomes a reality. And this is why, you know, it's so important for people to take that course we have on our website, because, you know, reading that course, and we're gonna add a module that will address this new paper as soon as we have it out. And it will be great because we can literally just go through all of the equations and explain what they mean. And that becomes like, you can like integrate that in your experience as you read it. So I'm pretty excited. We got 47,000 people taking the course right now. 47,000 people, and we need to get to 100. We got to get to 100 by September. Let's do it, folks. Let's get people registered. Let's take the course. It's free, it's easy, everybody can do it. I had my kids do it, you know, and then the discussion gets stronger and stronger, and we can talk about it, and we can transform all together.
Yeah, definitely. You can find the delegate course at the Resonant Science Foundation website. It's free to enroll. Definitely go and check it out.
Yeah. In general, people really appreciate it. And you can meet people from all around the world, you know, that are taking the course. You know, we have a forum there. You can participate and ask questions. And, you know, we have the research team answering, and we have these 2-hour meetings every month. And it's a lot of fun, and we learn together and transform together, and we're going to continue to update. So that's an update that's going to come soon. We will get a 7th module to our course, which is going to be awesome.
So should we move to some of these questions? There's a lot coming in.
Yes, I'm sure.
Okay. So this is from Dana Tomasino. It's on water. I want to help further the collective understanding of water as a communicator of energetic and multidimensional patterns of information. I've done some research on this early on. Do you have any insights on this? Have you done any work on this yourself, or do you know of others seriously studying this beyond Dr. Emoto's work, which I'm sure you're familiar with? So water as an information carrier and communicator.
Yeah, absolutely. I mean, there's a lot of really good work that was done by Nobel Prize winners on water information structure. It has been controversial. It's getting less and less controversial, but it has been. Um, do we have a staffer out there that could put Dana on, because that'd be great to have her.
She's on with
Hi,
us.
I'm already. Aloha, Nassim. I'm already here.
Hi, good to
Hi,
see. Hi, you're in
nice to see
Hawaii.
you. Not right now. I'm in near Las Vegas right now.
Oh, right on.
But yeah, I was in Hawaii.
Right on. Yeah, it's have you looked at the work from Montagnier? Is a French Luc Montagnier is a French biologist that received the Nobel Prize for having identified the gene structure of AIDS, and he worked, and then he realized that the water that packs the DNA actually holds the information that and actually William would be better at explaining this than me. It's his field of expertise. So William, if I say goofy stuff, stop me. But basically, Montagnier showed that you can actually transfer that information in pure water that has no DNA in it, and then inject the elements that makes up DNA, which should just settle to the bottom. But when you inject them, the water information actually reproduce the DNA, that the signal of the DNA that was actually sent to it electromagnetically. So basically, you put 2 vials in a Faraday cage with a little coil in it that's oscillating at 7 hertz, like the Schumann resonance frequency of the Earth. And then in one vial, you have this strand of DNA, but it's been diluted many times, so it's actually not in there anymore, right? So there was DNA in there, but then it's been diluted many times. The information is in there. The other vial has only pure water, and you put the 2 in the Faraday cage, you turn on the coil, you leave it there 18 hours, you remove one, and actually there is on module 6, in the section on the arc crystal, I think there is a link to a documentary about the discovery of Montagnier and the tests that were done by independent lab to confirm the effect. And basically, when you take the vial that hadn't had anything to do with that DNA strand, and you inject like the amino acid, that makes up, they all of a sudden arrange in the vial to a replica of the DNA strand that was in the little Faraday cage with it. And so the fact is that this totally proves that information is in the water, and it's the water, and it makes sense. Life emerged from the water, right? Water is not just a neutral background that doesn't matter, as described mostly, in current biology, but actually water is the source of the information. It's coming from the vacuum and the quantum state, from the hydrogen atom and oxygen atoms, and then it goes into the molecular state, and then eventually into the biological structure. And so that's the carrier of the information. As well, there was work that was done by another Nobel Prize winner, this one a Nobel Prize winner in physics, Brian Josephson. Brian Josephson received a Nobel Prize in physics for the Josephson junction. And he's from England, and he wrote a lot of paper. He took some serious hit from the mainstream for writing papers on water memory. He got tomatoes thrown at him and got banned from certain sites and physics sites and all this. You see, I'm in good company. You know, Nobel Prize winners get banned from physics sites as well. And you know, it's amazing the censoring that goes on. I used to say that people didn't necessarily get it when I would say that, you know, but now since COVID, I think people are seeing it more clearly, how much censoring happens. Even doctors, medical doctors that have, you know, even groups of medical doctors, you know, are able to be censored off platforms and so on. So, you know, so anyway, Brian's a good source as well. There is, of course, I don't know if you read the book, The Fourth Phase of Water. Pollack?
Yeah, the fourth phase of water by Gerald Pollack.
Yeah.
He's a professor at the University of Washington.
Washington.
I actually met Dr. Pollack, but I haven't read the whole book.
Okay.
That's something else to explore. And I've heard of Montagnier's work, but I haven't explored it in depth, so I'm going to look it up.
Right.
Josephson,
How about the
Josephson that you were talking, Brian Josephson?
Yeah, Brian Josephson. Yeah.
So I'll look that up as well. And
yeah,
it's been a passion of mine for 30 years, and I did some early work on it at HeartMath and even before HeartMath, and it's being re-enlivened right now, and I'm wanting to create a group that specifically comes together to study this and bring in like collective intelligence on this. So
maybe start a thread on our forum.
All right.
For people that are interested.
Okay. Awesome.
That'd be great.
Awesome. And just one more thing, I believe that, you know, both the water within us, but also the ocean. I mean, the ocean must be a source of like multidimensional patterns of information that we have yet to really understand what's going on there. I think the dolphins and whales might tap into that, but I think we have yet to really learn what's going on at those levels.
Absolutely. There is so much to learn about water that we don't understand yet. And really, like, it has to do with the source of life. And you know, when we write these equations I was talking about earlier, we ended up with an equation at one point that's related to Einstein's constant. And I'm not gonna go into the details there, but we ended up with basically an equation that described this, the Planck oscillator like a fluid, a fluid with a pressure, with a flow of information, and you know, we haven't had time to explore how to connect those equations directly with the fluid dynamics of water. But we're hoping, I know it's gonna get there. We just haven't had time to like concentrate on it, but we can see that it will eventually replace the Navier-Stokes equation or solve the Navier-Stokes equation in a deeper manner, which there's I think $1 million prize for better fluid dynamic equation, or for solving Navier-Stokes in an analytical way. So this is, you know, it's related to some of these equations I'm writing in physics right now.
Cool, that's awesome. Thank you very much for addressing that.
Yeah, thank you.
I'll try to start a discussion on the forum. I haven't delved into that yet, but I'm going to participate.
And Emoto's studies were good, but they were not done appropriately in terms of scientific rigor. And he was the first one to admit that. I think it still has some validity, but I don't like these experiments should be reproduced in a much more rigorous way.
Yeah, I think so as well. Yeah. I think it pointed to something, and now we have to explore it deeper.
Exactly. Yeah. Yeah. Thank you for your question.
Thank you. Mahalo.
Mahalo. Aloha. We'll see you next time.
It's really fantastic because the work of Montagnier and Gerald Pollack really both show how life could have emerged from water. Because you know, Montagnier's work with DNA, and Pollack has explained in a publication how the cell membrane could have formed from exclusion zone water, easy water. And those are the two most important structures for the basis of life, the cell, the membrane and the DNA. And both of those have this water memory imprint that you can reproduce them from just with the structure of the water. And so it's pretty exciting to think that we might be able to link that to the vacuum structure with the equations that you and Dr. O'Leary are discovering.
Yeah.
We could find the entire thread to the emergence of life. So
yeah, yeah, absolutely. And you know, and it starts to describe life in a more fundamental electromagnetic way, you know, as well. You know that like it's an information transferred through a medium, right? And yeah, it gives a completely different view of the genesis of life, but not just like on Earth, like the genesis of life in the universe, right? And at the most fundamental level of the description of life, like the formation, how such a thing could happen that all of a sudden the formation of a cell and, you know, and DNA and all the information that's needed for that to happen could happen, which is really like an energy potential relationship. Again, it's the same thing. It's this fundamental relationship between the volume and the surface of a sphere that we call a cell, right?
And I think that's going to answer the question, you know, how likely is it for there to be other life in the universe? Because it seems like something that would be so rare to happen, because you've got all these trillions of molecules come together in just the right way to make this amazingly complex system, far from equilibrium, thermodynamics, and all of this. But if there's this mechanism going from the low entropy information state of the vacuum, and the water's acting as a medium of information transmission, you can see how it could actually be a very commonplace occurrence. Life would be probably just about everywhere you look that you have liquid water.
Exactly. And now you have a mechanism so that it wasn't just chance that made life. It wasn't just random occurrence, but it was actually fundamental to the mechanics of creation, that like it was gonna emerge. It is emerging. It's not like it's just the way things are. It's a direct consequence of the mechanics of physics in the universe that life would emerge. It's a direct consequence that can be predicted, that can be understood, and really at the fundamental level that can change very dramatically the way we address health and healing and, you know, many different things. You know, all of a sudden starts to give credence to electromagnetic devices and so on, you know, that can change the way we do things.
In life, serving as that feedback mechanism, it's not going to be a chance occurrence that feedback mechanism is emerging in the universe, because that's one of the primary factors shaping the properties of the universe.
Exactly, exactly.
So we've got a very interesting question here that might be a challenging one. This is on the neutrino. So this is from Simon at Space Variations. Simon asks, is the neutrino relevant to your research and equations on defining the matter being generated from space itself as organized information, including the gradient scale shifts happening at all times in space memory you speak about? Can you share your perspective on this neutrino, a neutral subatomic particle with a mass supposedly close to zero, with half integral spin, etc.? How does this relate to the Planck scale field of mass information or sub-Planck scale, if at all, given your research? Does this relate in any way to the possible speed of consciousness in your new research?
Oh, wow. Oh, wow, that's a good question. Do we have him online? Let's see if we can.
He's on.
He's on? Oh, hi.
Hi, Nassim.
Hi, good question.
What a privilege.
Oh, thank you. Oh,
Yeah.
I like your drawing behind you. Is that like it's a painting or is it
That's an architect. I'm an architect. That's a project on my property in Utah, unrealized. Bringing together astronomy with contemporary physics.
Wait, you're cutting up. You're cutting up. It's hard to.
Is that easy? Can you hear me now?
That's better. Okay.
Yeah. So it's a project that's bringing together indigenous astronomy with contemporary astronomy. It's a dream I've been working on since the ninth time.
Do you have a headset? Do you have a headset?
No. Sorry.
Oh, okay, there. Now it's good again. Okay.
Okay.
Yeah, I think you gotta speak really close to your mic for some reason.
Yeah, or maybe louder. Is that better?
Yeah, this is really good.
Okay.
Yeah, so it sounds like a relationship between astronomy and
A Native American astronomy and contemporary astronomy.
Oh, wow. Oh, nice.
Yeah, and it's an architecture dream, and I was introduced to you by watching an interview on consciousness to bring cosmology and architecture together. Something sometimes Buckminster Fuller, I think, talked about in terms of it would be, could we actually, experience the spin of the Earth in a building by watching light and the reverberations of sound and how to do that. These are oculi that bring in light, and then those are the landscaping in the landscape in the site.
It's beautiful. For your question. So, I hadn't taken much time to look at the neutrino because as well, the neutrino is somewhat of an artifact of the standard model, but I wanted to, but it kind of popped out in our equation all of a sudden in the last few months. When we were doing the scaling, right, we realized there was a scale below the proton, but above the Planck that was a nice match for neutrinos. And so we identify it, and we actually have some data about the neutrino that the mainstream doesn't have. Because of the scaling, all of a sudden we can predict things, right, about the neutrino that we can't measure, right, that we might be able to measure in the future though. And so I'm very excited about this. I don't have the equations in front of me right now, so I wouldn't be able to give you exact numbers of what we found. But it seems like it is there, that we were able to output the muon, the taus, all the particles of the standard model. It's all showing up in our equations, but the neutrino as well. And it's really interesting how it shows up. It seems to have its own scale, and it may be part of, like the information transfer from the Planck to the proton, right? It might be the vehicle, at that scale that brings the information through. Can we call it so just to clarify, from these equations as well, we were able to extrapolate the scales below the Planck. So because there's a problem in physics, it's called in some case hyper-Planckian problem, or it's called the sub-Planckian problem, which has to do with black holes and Hawking radiation. That if you look it up, you'll find this in hyper-Planck or whatever, and basically you see that there's a problem. It's like, well, when information past the event horizon, it would have to be sub-Planckian, basically. And so basically, we push the equation to give us the lower scale of the Planck. And when we did that, it was really kind of cool, because it came out just right, so that the Planck would be in the middle of the scale between the sub-Planck and the universe. So imagine the sub-Planckian scale. The Planck is so teeny already, so small, right? Well, the sub-Planckian scale makes the Planck the middle of the scale, so that the distance in scale between the sub-Planck to the Planck is the same as between the Planck and the universe. And then we calculated the speed of light, the speed of the sub-Planck, basically. And it was below, so it was 10 to the 40th time faster than the speed of light, right? So the speed of light for the sub-Planck, the speed of light would be like not moving, like it would be like almost stillness, right? It would be like if it all of a sudden had to stop or slow down to the speed of light, the sub-Planck would feel like it hit a wall, a solid wall, right? The speed of light would be so slow. And when the speed of light is 3 times 10 to the 10, meters per second. That is fast, right? We think of the speed of light so fast, but think of it in the scales of our universe. The speed of light is super slow, right? It takes thousands of years, millions of years, billions of years for light to come from a far quasar or something, to us. So it's actually really, really slow. But then if you calculate the information transfer across the universe from the sub-Planckian speed, then the sub-Planckian speed of information across the universe is approximately, don't hold me to this because I don't have the paper in front of me and it's like I'm dealing with so many numbers, but it's about 10 to the minus 27 seconds to cross the universe for a sub-Planck, right? Right? Where light takes millions of years, right? Billions of years. The sub-Planck takes 10 to the minus 20 seconds, right? Or 27 seconds. So and I think that's the speed of thoughts for the universe. I think that that's what we call entanglement. I think that's why we think of it as instantaneous in entangled particles. but it's so fast we can't measure, you know, the difference in time between the information leaving and arriving. So we think of it as entangled or, you know, instantaneous. Yeah. So, and I believe that's the speed of thoughts, meaning that when you're thinking, when you're sending information to the universe, when you're interpreting the universe gets the information that you're sending it at the speed of the sub-Planck, right? And then after that, it's like entropy, right? It's like slowing down, right? And the slowing down part produce energy effects that we call our reality. Basically, you know, the entropy of the system across the scale, the neutrino being one of those scales, right, is transferring, is leaking energy from the system, if you'd like, the entropy of the system, the thermodynamics of the system, which produces our reality, which is a thermodynamic reality, like a black body radiation type of thing. So does that answer your question?
Yes, yeah, beautiful. Thank you very much.
Thank you.
There's a whole perspective of bringing it together.
Yeah. And that's what's so beautiful about these equations, is that it gives you such a large perspective. You know, when you find something individual, you get its relationship to the whole because you have the whole, right? Yeah. So then it makes sense. It's not some kind of isolated thing that you can't figure out what it's doing, right? You see the relationship, and it's so beautiful. It just blows my mind.
Thank you.
Thank you. I appreciate it. That was a great question.
Ah, yeah, that was interesting. It has my mind thinking about technological applications.
Right.
You know, because when you start traveling interstellar, intergalactic distances, you're not going to be communicating using electromagnetic waves, light.
Right. At the speed of light, it would suck.
Yeah.
You know, you would say hello and you'd get the hello back, you know, like a few thousand years later. It'd be like, well, you know, having a good conversation could be difficult.
That's why we should not be looking for advanced communications in radio waves, you know?
Correct. That's why SETI is not finding, you know, because, you know, evolutions like ours that are communicating in the electromagnetic band of the speed of light must be fairly low, you know, graded, you know, civilization. Like they're kind of like baby, you know, societies that are just starting on the technological development, right? We've got like 150 years since, you know, we got, you know, we got the telephone only 100 years ago or so, you know. I mean, it's like, you know, for the universe, that is such a short amount of time. It's like a bleep on the like, it's not even a bleep. It's, you know, 150 years for the universe is nothing, right? So even for the galaxy, it's nothing, you know. Like for the galaxy, it takes 250 million years to go around once, right? So 150 years is not even like on the map. So of course, you know, societies, and we're just about to start using quantum entanglement for communication. We already were successful in transferring photons from a satellite, information from a satellite to the ground using quantum entanglement. You know, this is very much, you know, on track for us to have, you know, information transferred through quantum entanglement within the next 15 years, 20 years. you know, our cell phone are not going to need repeaters anymore. Then, you know, for people worried about 5Gs and 4Gs and all this is going to go away. So, you know, so the time period in the evolution of a society in which they would be using electromagnetic waves to communicate is so short that the probability that SETI would hear a civilization that's right in that period in the universe is very, very low, right? Never mind that, like, we might not get it, it might bounce off, and when we miss it, and you know, all the other variables that can make it so we don't get it. It might be in a signal that we don't recognize as anything alien. For instance, we might think it's a star that's, you know, pulsing something or whatever. So, you know, there's so many variables that probabilities of us hearing, you know, another civilization is very low unless we were listening on the quantum channels, on the entangled, on the quantum network, right? And we haven't plugged into the quantum network yet. So, you know, then we might start finding the communication, because clearly advanced civilization, not much more advanced than us, would have figured that out.
Yeah, any intelligent species is going to see pretty quickly that the artificially generated EMF is not the way to communicate. I mean, not even to mention, you know, the effects that flooding your environment with all these different EMF frequencies are going to have on the biological system. It's got to be just a really quick transition
Right.
for any intelligent species, any intelligent
Otherwise, they
civilization.
probably wouldn't survive, because they keep cranking the power on the emitters to get more and more information through. Eventually, it will crank up the power to the point that biology comes apart, right? You know.
Well, it's so. Will there be possibly calculations on how much information can be transferred, like per unit time? Because
from these equations we're writing, yes, absolutely. We actually started to think about that, and we will be able to, you know, see. I mean, it's just a beginning. That's the thing, is that the core is there now. There's so many different, you know, avenues that we have to dig in, and so that's why we're excited to bring it to the world, and then, you know, collaborate with teams all around the world to bring all the different applications and implications of the theory.
Yeah, it's gonna take years and years to explore all the different avenues.
Right.
Wow, it's exciting.
Yeah.
So this is another really good question. This is from Pascal Barrett. So the recently published 3D map of the universe called EBOS reveals that matter, filaments, and voids define the structure of the universe at its 380,000-year-old premises. According to the EBOS program calculations, the universe expansion speed is 10% faster than the estimated Hubble constant of standard physics. The question, Nassim, do you have time to address these issues? If so, what's your take on them? There's all these new calculations for the Hubble constant coming out. Where do your calculations show on these new developments?
Our calculations are right in there with the latest values. Actually, it pretty well nails the latest values, and certainly as well nails the latest values for the temperature. So, you know, the great thing, again, because those equations are unified, is that, you see, the theory doesn't just say, oh yeah, this is the temperature, and then leaves you hanging, right? Because it's unified. it gives you the temperature, it gives you the acceleration, it gives you the radius, it gives you the mass. So now you have all these parameters to define, so you know how precise it is, because if you change one variable, the other change. So and then they're wrong for the measurement. So now it's highly tuned, and the acceleration. So in the acceleration, first of all, the fact that this structure in the universe is really important. That they are discovering, yes, there is structure in the universe. It's not just completely random, and that means that it's most likely polarized. It means that there is geometry involved and so on. But as well, that the relationship. Oh, we didn't get that person on. Maybe we can get them on.
Pascal is on with us.
Oh, he's on with us. Hi, Pascal.
Hi, Nassim. How are you?
How are you doing?
Good. I'm in Ottawa. Yeah.
In Ottawa.
Not far from Montreal.
Oh, wonderful.
And not far from Sudbury, where there is a neutrino lab, as you know.
Yes. Very good. Yes. And there is an institute there, the Parameter Institute, that does pretty good work. There's are you a cameraman? I see some.
Yes, I am.
Oh, wonderful. Oh,
yeah, that's my Neil Armstrong model on the moon.
Oh, wow.
Yeah, that's the same model.
That's the same model he had?
Still works. Well, I have not of them, but 100. I'm a collector. Yeah.
Oh, wow.
This model, what is special is that it's more than 50 years old and it still works. And it has about the same lens that Neil Armstrong had, except that, of course, there are a few differences. The magazine is smaller, and you know that when they went up back on the Earth, they left the body on the moon. So there are 12 bodies on the moon, and they brought back only one because I suppose they were unable to detach the magazine from the body. So when you go on the moon, please bring me back one of those for my collection.
Okay. Well, maybe I'll just pick you up on the way, and we'll go and collect those.
That'll be great.
Collection.
Yeah. So about the, I don't know exactly, I haven't understood everything you said about the Hubble constant, but they say that this EBOS experiment that was made with telescopes from your neighborhood in California and from Mexico, they've discovered that the Hubble constant was 10 times faster than the standard physics. So 10%. How does it compare with your calculation?
10% faster, or 10 times.
It's the same thing?
No. You said 10 times faster.
10 times faster? Well, that's what?
10% faster.
10%.
Well, so a relatively small margin.
Right.
Well, that's exactly what the recent study, the EBOS pictures study, says, that it's 10 times faster. So you're right on then with this study.
Yeah, our values match the latest measurements. So so to be clear, there is multiple measurements and they don't agree with each other. And the latest measurements don't agree with the earlier ones, to the point that the standard model of cosmogenesis and expansion in the standard model is failing, right? So there's a lot of discussion about the Hubble constant right now. And so basically what we find using our equations is in the upper means of the latest measurement, meaning we agree with the upper means of the latest values. So
That's
it's
great.
very, yeah, it's very good, because you got to consider that the equation is coming from the Planck scale, right? And it outputs the acceleration, and we could easily be off by an order of magnitude, right? But we're not, we're actually exactly where the latest measurements happen, or
Wow.
yeah,
Wow.
in the means. So it's very interesting. And I want to as well mention that the expansion of the universe, and the confusion might come from this, is that the expansion of the universe is not what physicists think it is. Okay. It's not the universe growing like this, most likely. Okay, meaning it's growing like this, but at the same time it's circulating inside, right? So because the matter is circulating in the universe, right, and it's expanding, you have a compounding effect. It's more complex than just a bubble expanding.
Yeah.
And that's why there's some confusion. But our equations are very, very precisely to some of the latest measurements.
Did you have the chance to look at this EBOS map of the universe, where they say that they have at the age of 380,000 years old, the universe had voids and had many voids, and of course a given structure, and they show a picture of that time, very early universe.
Yeah, this came across my desk, but I didn't study it enough. I need to study it more. But when I saw this evidence that there was structure in the early universe, I was very excited, because, of course, this would be part of the way the universe evolved, because the universe is spinning. And the standard model thinks the universe is not spinning. And that's the error. You see, when something spins, it's polarized and it has structure, just like a galaxy, right? It has arms, and in between the arms, there's voids, right? So you could think of our universe as like a huge galaxy. And that's why we're finding like places we're calling dark flows, where there's not much stuff, right? And then walls where there's like all these superclusters all in the same wall. Those could be the arms of our universe, just like the arm of a galaxy. And you can imagine as well that material in the universe could be going away from us, right? Like if the universe is a double torus and we were at the equator, then there could be material going away from us,
come back,
and then material coming back, right? Exactly. And so that would make it difficult for you to be able to get accurate measurement of the acceleration of the universe.
Okay, one last thing, if you don't mind. In your next conference in French, I have a catchphrase for you to resume your thought. Le monde est une onde. The world is a wave. So, and onde is encompassed into monde, and monde starts with M, which means love. So I leave that with you.
Oh, thank you. And I thought you had a French accent. Vous êtes québécois, vous êtes français?
Je suis québécois d'origine, mais je vis en Ontario depuis 1963.
Wow.
Yeah, I'm 73 now.
Wait. Well, hello to all the Canucks, including all the Quebecers out there. Bonjour les Québécois.
Oui, there are many of us.
Yes, wonderful. Nice to meet you.
Thank you, Nassim.
Thank you. I appreciate your question. It was a good question.
So the next question we have here from Christiana Eltrian. And I don't know if you know, Nassim, but we're using a voting system. So, in order to get some of the more popular questions, I'm selecting from the ones that have the highest votes. And this one, it definitely has a lot of votes. It's a
How
very,
can you tell where you see the votes?
so in the Q&A in the lower left-hand area of the question, there's a thumbs up.
Oh, yeah.
Yeah,
Okay, I see
yeah.
it. Okay.
This one has the second most votes on the board. So,
Okay. Okay.
so can you tell us something about the human body's capacity to change shape? That is, shape shift. I remember you referred to this in some conferences.
Yes.
And Christiana is on with us.
Christiana, that you would ask me this question.
Oh, what's a girl to do? That
You always
thing.
send curveballs.
No, it's because I love you so much, and I know people want to hear this stuff from you. And plus, I had a class recently where two of your team participated, David Knox and Andrea Malone. And David has asked me specifically this question about your approach on shape-shifting. I said I'm going to ask you today, and then I'm going to detail.
Well,
I didn't want to make any mistake and wanted your approach. Oh, my battery is going off. Okay, go ahead.
are you in Romania? Are you being a good girl?
I just got down from the Sphinx now. I was there all day.
Wow.
I'm having a blast. I just got home.
Oh, wow.
I didn't have time to change yet.
Ah, how
Yeah.
was it at the Sphinx?
Had a great day. You can
Yeah.
tell. This is my face after the Sphinx. It was great. It's fabulous. I sent you a pic.
Oh, wonderful.
You'll see. Mm-hmm.
Yeah, for people that don't know, we're talking about the Romanian Sphinx.
Mm-hmm. Yeah, it's a Sphinx connected to the one in Egypt. And there was a lot of helicopters today carrying stuff. I didn't understand what they were carrying, but I'm going to research that.
Yeah, because they're in the middle of nowhere there, no?
Exactly. It doesn't make sense to carry stuff over there, but yet they were.
And there's a cave underneath that was opened by the governments at one point, right?
Yes, and it's not made public.
Oh, I'm sorry. All right.
No, it's okay. I mean, I'm just saying that it can be visited or, yeah.
Oh, yeah, it cannot be visited. Isn't it guarded?
It's quite hidden.
Okay.
Not only.
In any case, yes, shape-shifting. Well, it's important for people to realize, and this is something we keep forgetting, is that we're constantly shape-shifting, right?
Yeah, definitely.
We think of ourselves as stable because we see our body every day, and we assume because it looks the same, it looks the same. Very, I should sound the very rough level, meaning
At the basic level, yeah.
Yeah, on the basic level, meaning your hair looks the same, as when you looked at yourself yesterday, right? But they're not the same because they grew, right? And your hair on your legs or your leg, I'm talking about my legs. You don't have.
Thank you.
Yeah.
Hopefully, yeah.
But you never know after being in the woods for a while. But
no, it's okay.
Your hairs on your arms, whatever, they look like they're the same as the ones yesterday, but they grew, right? And they changed, and your skin changed. Like every 7 days, you change your whole skin. You don't have the same skin. You're not the same person. And within a few months, you change almost all of your organs. You've changed and then, over a period of 3 years, you change your whole body, like all your bones. You change your bones in every few months, right? So you're actually constantly changing. it's like you're constantly, I'm going to do this one day. I've always wanted to do like, you know, a cartoon where you would see, you know, all the pixels that we're leaving behind and the pixel like that are being reconstructed constantly, you know, and because we're constantly transforming. So
Absolutely.
this is something that biology doesn't know. Like, why are we, when we're transforming, why are we keep transforming to the same thing? Meaning, right? Like, where is the information that says to the cell, when you change, when you divide and you change and all this, continue to make your nose the same way and continue to make your fingers the same way, right? Like for instance, your imprint on your finger, your print on your finger, right?
Yeah.
It's specific to you, and it stays specific to you for your whole life.
Your whole life, yes.
Yeah.
How does it remember?
How does it know that, right? So like for instance, because in a few days, it's not the same skin anymore.
Not the same finger, yeah.
It's not the same finger, right? And it's like you took that print when you were like, you know, 10 years old, and now you're like, you know, in your case, you're 22, right? And
Well, around 37.
and it, you know, 10 years later, 20 years later, you know, 50 years later, you take that print and it's the same print. How is it? Well, where's the information for that to happen? And never mind, like, you're constantly rubbing your fingers, you're constantly touching things, you're constantly cutting yourself, you're constantly doing all kinds of things to those 4 fingers, but it always grow back to where it was, right? So where is the information in there? Well, the information is in the structure of space, meaning that you're just growing back to the space, the information in the space, right?
Yeah.
So let's say that you could change that information.
We actually can, yeah.
Let's say you can, right? And let's say you actually can. Well, that means your body, when it grows, it would have to regrow into that new information set, into that new way of being, in that new like information structure, and you could change, you know, the shape of your nose, or you know, the prints on your finger. That could be useful.
That would be useful.
It could be scary for the police, but you know, so basically it shows you how, and I mean, people that lose limbs talk about it, right? They talk about how they feel like the limb is still there in the space.
They still feel pain sometimes at the level of where limb was, yes.
Exactly. Or like when you know, like it's been shown that if a child before the age of 10 cut their finger up, like loses part of their finger, if you don't sew it, it can regrow, right? So what is it regrowing in? Or you know, like a frog, you know, they can regrow their legs, or you know, like there's many animals that can regrow their limbs. So it's like the information network is in the space, and the particles, the molecules are just refilling the space with the information that was there. So
yeah,
I find it very plausible that you could change the information, or you can enhance the information. And if this is true, Christiana, that would mean that there would be techniques that could be developed, and there was a doctor in the 60s, I believe, that worked on this and got some really good results. There would be techniques that could be developed in which if you lost a limb, you could regrow it.
Regrow it, exactly. Or for example, remote healing. Remote healing is shape-shifting.
Yeah.
When you instantly make a tumor disappear, you shifted the shape of a specific body part that was ill into a body part that is healed, and that's shape-shifting. Or for example, you speak about remembering information in the body from this lifetime and the limb feeling pain at the level of a limb. But what about people that are born with birthmarks and you feel pain? For example, I have a birthmark under my left rib and I feel pain in that area that goes to the fingertips, but I never was hit in that area in this lifetime. You know? So it's a memory so body restructures information even from other timelines. That's what I'm saying. And it's been researched, I believe.
Becoming more esoteric, but yeah, there's definitely, so for instance, there's a case in India, right?
Yeah.
Where this child at the age of 5 said that he remembered his previous life. And he said he was oh, you got your rabbit there. He's so cute.
He's watching.
He's watching. He's listening with his big ears. What's his name? Rabbit is his name, right?
Yes, exactly. I keep it simple.
How do you say rabbit in Romanian?
Iepure.
Iepure.
Iepure, yes.
I
think it's the first Romanian word you learned, I remember.
Okay. So when so this child remember his past life. He told his parents that he was a thief and that he was shot in the head. He said where, and he said he was shot in the head, and he pointed at a birthmark that he had on his forehead. And so the kid was insisting on this. So the parents eventually tried to figure out if there was such a person, you know, in their area when the child was born or something. And they found that the very day that child was born, a thief, a few blocks away from where they were, where the child was born, was shot in the head, exactly in the same place where the child has the birthmark, right? So imagine that. That means the birthmark would have had to happen within the few, you know, it was an imprint, the last minute just before it was born, right? And then
and he was quick to come back also. I must notice.
Right. Well, I believe that's the case in many cases. I believe if, you know, I personally think that past life is a reality, that life and consciousness, you know, continues past the body, because I see no reason why information should be lost. This is straight up physics, you know, no information can be lost. And a person is definitely a set of information, right? And I see no reason why it wouldn't sustain and why it wouldn't just use some more matter to come back in. I think that's very consistent. And there's many evidence of that. But
they're doing research now in Tibet and in India. It's a frequent case to just check the house where the child says it lived before, and the parents go with the child and they find the genes with the note he left and stuff like this. It's common thing.
Right.
It's a documentary.
Yeah, it's documented. So basically, you know, so not only is your body, we know your body is holding very specific shape based on your genealogy. for instance, right? So that's not so esoteric. We know that. But how is it holding the information of all the genealogy before you for thousands of years? How is it holding that? Where is this information? You got to tell me that because of a few genes, right, it has all the information of thousands of people before you? No.
Not exactly.
Yeah, most likely not. So maybe the genes are like the antennas tuned to a set of information. And maybe when you incarnate, you always incarnate in the same set because you're continuing a set of information. You see, you can't
A
just
blueprint.
yeah, a blueprint. And this is maybe why people say, I knew you in the previous life, or there was a relationship, or, you know, because there's these timelines, right? These incarnation loops that are occurring. So it's a very interesting subject, and it can be explored very deeply.
And you know, also the way that DNA replicates, it's called semi-conservative replication. So you've got the two strands, right, to make the double helix. They unwind, and each serves as a template to make two new double helix strands. Then that goes on to form the gametes that, you know, make the new person. But because of that semi-conservative replication, you have an unbroken chain of entangled DNA strands.
Right.
You know, so you've got a mechanism right there where this entanglement can be conserved down thousands of generations. And you know, that entanglement, that's like in the space-time structure.
Oh, that was awesome.
That's cool.
William, you're so brilliant. I love you, man. You know, it's great. It's great. Yeah, totally. So, you know, we could write the mechanism of information entanglement across generation, and eventually we might be able to even output an equation for information reincarnation structure within the, you know, gene information, like entanglement flow, right?
That would be interested to watch. So the basic question was, how do you shapeshift? What's the method? I mean, what would you say would be possible for that to happen? For example, if you want to change your nose shape, or the ears if you don't like them, or something like that. or an illness.
Experiences, but I'm gonna skip that.
Yes, no, or an illness, for example. You
Yeah.
can shapeshift an illness into health. That would be important to know.
Yeah. It has to be that you have to be very deeply connected to the structure of the vacuum, meaning you have to be able to deeply influence it. And that takes some concentration and takes some, you know, deep empathy with the structure of space. And in some cases, it can be difficult. In some cases, you know, some emotional entanglement have to be undone, right?
That can block it, yes.
Unblock, and some of that can be difficult for you to unblock because you might be blind to it. You might not know.
You don't see it.
Exactly. And that's why illness, I mean, happens. You know, I have challenges, you know, people that are very evolved can have challenges. You know, it's not that straightforward. It's not that easy, right? It's not, it can, and then it might be easier to change the shape of your nose than to like get rid of a tumor just because of like all this entanglement of DNA throughout the generation and all this, you know, they might be things that are harder to change than others.
The cause behind it is important too, yeah.
Yeah, certainly knowing that you have that opportunity, that you have that power is a really good step forward. And then you might as well bring in your field what you need to heal. So it's not just internal, but it's external as well. You might bring it from the outside, right? So it's not like a rejection of what can help you from the outside, neither, right?
Yes, absolutely.
It's all the same loop. It's all the same thing. It's all one thing. So that was a good question. Hi, Rabbit. Oh, how do you say rabbit again?
Yepure.
Yepure. Hi, Yepure. He's so beautiful.
Hi.
He's well nourished, I can tell.
Yeah, mostly prana. I was away all day. But he's happy like that. That's no problem. It's okay. Yeah,
Thank you.
no, thank you so
to,
much.
It's good to talk to you. Thank you.
Good to see
question.
you. Bye.
Bye, Christiana.
Good answer. Thanks.
Bye-bye.
Enlightening. So I think we've got enough time for at least one more question. And there's one that I think would be really important to get some of your comments on, some of your opinions on this. It has to do with Dr. Salvatore Pais, an engineer with the Navy, who's developed several US patents for this, what's often referred to as like sci-fi technology. And you know, it's really interesting that the Navy is producing patents recently on things like UFO type propulsion. And it's kind of coinciding with the US military industrial complex making official declarations about known and documented and investigated UFO activity and possibly even recovered off-world craft. And these are like official announcements coming from the Pentagon and stuff.
Yeah, just 2 weeks ago, they announced that they may have parts of extraterrestrial craft that were not originated from Earth. I thought that was cute. It's like, oh, really? Oh, cool. You mean all those crazy people that talked about Roswell for all this time? Maybe they weren't so crazy? Okay, okay.
When I hear may have recovered stuff, I hear we have recovered stuff.
Right, right.
But that might just be me.
Yeah, exactly. Otherwise, why are you talking about it? What, are you confused? Or maybe you lost it in the big, in the big warehouse, Oh yeah, where was that? Where did I put that UFO?
All those people are looking less and less crazy.
Yeah, exactly.
Yeah.
Exactly.
So this was from Mohan, who's asking if you could please comment on these patents using an electromagnetic propulsion system, room temperature piezoelectricity, which you and Dr. Rasher actually worked on. Room temperature piezoelectricity. Mm-hmm. Actually, you've worked on all these things. Use of an inertial mass reduction device, high frequency gravitational wave generator, electromagnetic force field generator. What comments would you have on this whole emerging phenomenon?
Right. Well, a lot of these things as well were investigated by these agencies very early on. That's the thing. It's like it's emerging now, but it's like, I remember in the 90s talking with some of the people that were involved in these research, Pudov and many others. There is definitely been a long life, interest, a long-standing interest on these devices. A lot of advancements were done, and it's emerging now. And they have to do with extracting energy from the structure of the vacuum. All of these devices, I mean, you can find it in all of the basis theory of these devices. And so much more need to be done. It's unknown exactly what's known inside the military industrial complex. But certainly they're starting to open the doors a little bit. And interestingly, a lot of it coincide with some of the research I've been doing, and which has to do with, you know, high superconductor or superfluid plasma, you know, piezoelectric effects and crystals and so on. And all this leads to a completely different world. So yeah, patterns are emerging. There, you know, the whole idea that energy can be extracted from 0 point field and from the quantum field and so on is becoming more and more popular. Some of it has been there for a long time, but people don't know about it. For instance, you know, Sonny White at NASA that has been working on the warp drive for the last, what, 20 years? You know, by using vacuum fluctuation, trying to cohere vacuum fluctuation into a lens and open wormholes and so on, warp space-time. You know, the EM drive is something that's been tested by Sonny White now and confirmed, you know, which is a what used to be called the impossible drive or the impossible thrust. You know, it produced thrusts without shooting anything off the backside. It's just basically a conic can with microwave, you know, waveform bouncing around in there, creating a little bit of a gradient between the front and the back, and boom, the thing starts moving in space. It produced thrusts. It's now being included in some of the satellite designs for NASA. You know, so it's not like it's not real. So these things are emerging now and being patented and so on. So it's like a whole world is starting to emerge. And people that are not in that field are not necessarily aware of it. And the media is not necessarily covering it. But they will, because it's eventually going to run your car and your house and your whole society. You'll just have a little piezoelectric crystal running all the power for your house and your car and everything. And so all this is emerging now.
Can you hear me? Is my voice coming through?
Oh, yeah. Oh, there you are.
Oh, good. Yeah. Well, I was really excited. I found out recently that back in like 1959, Otis Carr had invented some kind of device that would, because he was working with Tesla.
Yeah, we're having a hard time to hear you. Can you talk closer to your mic or?
Oh, okay. Yeah, I think it's
better. That's better.
Okay.
You talked about Otis Carr?
Yeah, Otis Carr.
Yeah.
Was working with Tesla.
Yeah.
And he invented a device that could transport somebody. I think it was more than just anti-gravity. It was conscious control. And it was.
Oh, we can't hear you anymore again. Can you get?
Oh, okay. I'm sorry. We'll just have to use another time. I'll ask the next one.
I'm sorry. I'm getting like I'm missing sentences. Yeah, you were talking about his invention that produced gravitational effect and how he was. Yeah, it was amazing. He got shut down, but while it was going, it was amazing. Yeah, a lot of these things had to do with piezoelectric effects of crystals and so on. And yeah, and now it's emerging. So it's been a long time going. We've been, like I've been saying all this time, it's not like we don't have the solutions. We just have to get the structure of the infrastructure of our society to be in the right place to allow these things to emerge. And I think we're finally getting there. So it's really exciting. It's really exciting to see it come out. And what seemed really crazy and weird in the old days, you know, is starting to become the norm. So that's really incredible to see.
Thank you, Mohan. Yeah, the mic just it keeps cutting out, so we can't really get a complete sense.
Yeah, I don't think you can get anything. Well, I'll talk next time.
We hope you'll join us next time, and we can maybe discuss it in more detail.
Yeah. No, but that was a good question.
So actually, we do have a little bit more time here. Let me see. Charlton Warnke asks, if the universe gets larger, does the proton get larger or more dense?
Oh, that's a tough one. If the ratio is invariant, then everything should be growing at the same rate. So you wouldn't see the difference. You wouldn't know, right? So that's definitely a possibility. And there was multiple theories about 5 to 6 years ago that emerged, you know, talking about scale invariant expansion like this. And so since everything grows at the same time, all the pixel size relationships stay the same, and nothing changes, and you can't tell. So this is a possibility. Like I said, though, it's not that simple. Meaning, the expansion of the universe might be an artifact of the way we measure it. You know, meaning that it's not necessarily, I believe it did expand from the size of a proton to the size of the universe that it is today very, very rapidly. The equation shows that because it escaped another bubble universe. And when it did, it entered the larger universe we're in, which has a lower density. Is the person online? Are they there? And so when it did that, it grew very, very fast to the size of our universe. But at this time, our universe may be stable in size, but the material in it is circulating. And because it's circulating in certain ways, it appears to be redshifted, or it appears to be moving away from us. As well, now this could be combined as well with the birefringent nature of space, meaning that space not being empty may be the source of the slowing down of light, and we could say it in that sense, that would produce redshift and make us think that it's expanding, when in fact it's just the way light is moving through the structure of space. So, you know, it's a complex issue. It's a complex concept, but yes, to answer generally to the question, if the universe does very specific ratios, fundamental ratios, in order for everything to stay in this state of dynamic equilibrium. So it's not an equilibrium where nothing moves. It's an equilibrium where everything moves, but overall it's an equilibrium, right? So it's a dynamic equilibrium. Then, you know, if that, in order for the universe to maintain this dynamic equilibrium, then everything would have to grow at the same time. So it's you know, and at any scale that you saw, if you saw growth, then you knew that, like, you could see growth, because if you identify one scale, you could see it. And we kind of see that. Let's assume that the universe is growing. We can see as well that if we shrink the Earth 60%, all the continents come together very, very cleanly, right? So maybe the Earth grew. And, you know, we know stars change size and stuff. They expand before they eventually blow. And we call that supernova explosion, and stuff like that. So it's, you know, it's a complex question, but I would say generally yes.
Am I on here?
Oh, I hear a voice,
Yeah,
but it's very faint.
Oh.
We're having mic problems today.
Let me see.
Can you talk closer to your mic?
Okay, let me see if I can turn my mic up.
Oh, there I see you. Oh, I like the purple.
Okay, I cranked my mic.
Oh yeah, now I can hear you good.
Okay, yeah, that's 400 nanometer light. I've got black lights going, some UV. That's a water vortex.
Nice. It's running. I see it back there.
Yeah, nonstop. It rings at 432 hertz.
Oh, beautiful.
So
nice.
It's got a detectable field too. Like.
Oh, nice.
And that's a simple circuit tester. It probably picks up EM fields.
Wow.
It's pretty strong. So
yeah,
it picks it up at about 4 foot. So it's probably got an 8 foot wide field.
So wow. So if you put the coil in there and you put the oscilloscope on the coil, can you see the waveform?
What I did is I plugged a guitar tuner and a pickup, and it picked up A at 432.
Nice.
And it's also got an overtone at C sharp, and I looked that up, and apparently that's some type of Ohm frequency interval or something like that.
You should look at it on a scope. Look at the waveform. See what it looks like.
Yeah, I got to get better equipment.
Oh man, that's cool. Are you in your basement?
Yeah, I also got a galactic portal here that I opened.
This is the man cave.
Yeah, this is the man resonance cave. And so I got my guitars that I built there that have anatomical dragonfly and cicada on there. And
wow.
I painted a Trompe-l'oeil galactic portal there. I just kind of knocked the wall open, and which is cool because you can see the fractal. I based this off, this is actually Galaxy NGC 1512. I based it off the Hubble telescope. I actually kind of drafted it. I'm an actual, I used to be a registered architect by trade, and this must be the day for architects on here, but it's got black light paints too. So it glows. If I cut this light.
Thanks for having us in your man cave.
Yeah. See there? It's
Oh,
a
it
black,
glows in the dark.
yeah, yeah, it's black light.
Nice. Nice.
But
That's awesome. That's awesome.
so, but I've been, you know, I'm the kind of person, if I learn this stuff, I've been kind of learning this for, you know, 3 or 4 years. I'm going to go and try to do something with it, you know,
Right.
make my own version of a crystal oscillator.
Oh, nice.
This is,
The cuboctahedron.
yeah, it's concrete.
It's concrete.
Yeah, polished concrete, and I put monoatomics in it.
Oh, nice.
It's got azomite, and this, if you put it next to the right stuff, this will actually make an EM field too. So that's one material that I experimented with to put this on a pyramid tip, and my goal was to make a resonator shell to focalize the energy using waveguides, and to have a coil, a dipole coil on the inside to convert it to electrical current.
Power?
Yeah.
Wow.
I actually powered a LED with this on a pyramid tip, and something came along. I had a capacitor bank that I ripped out of a lamp, and it fried out the circuit.
Oh, wow.
You know, the cheap circuits nowadays, they're all like just paper thin, and I don't know, but it was in.
So you were powering an LED light from
Yeah, with a capacitor bank. With the batteries were actually expired and completely done, and somehow the pyramid tip, it was an 8-foot pyramid, PVC pyramid, and this was another experiment in materials with waveguides. This is PVC tubes with crystals embedded in resin.
Wow.
And I put azomite. I don't know if you know, but azomite's a volcanic dust that's found in Utah, and it has monoatomics in it, and microcrystals and magnetics. And supposedly when you embed azomite in resin, it generates a Casimir effect in scalar waves, because the particles are small enough at the monatomic level that the resin, when it crystallizes, it forces them together.
Wow.
So, wow. There, Ken Rolla, he calls it ormacite.
Nice work. That's a nice little man cave laboratory you got going.
Yeah, I'm just experimenting with the knowledge and structures. And
so when you disappear into your basement, you know, do you reappear like 3 days later and your wife is like, where were you?
Sometimes I feel that way. I'm actually out on the farm. So,
I see.
I've actually got a 15-ton pyramid down the hill. And so my goal was to harvest that energy in dipole coils and actually run some stuff.
Wow.
And it definitely has an effect, but what I've noticed about waveguides and pyramids is you have to power them. If you're using a metal pyramid, you have to put a current to it. I mean, you can plug your phone landline into it, but with regular pyramids, you know, and it seems to me from my observation that the more mass you have and the higher the tip is off the grade, the more effect you get. And
wow,
when you run water around them, it like supercharges them, powers them up. And if you look at all the pyramids all over the world,
they have water.
They have water. And so what I've noticed is that, you know, I'm in kind of a dry area in Oklahoma, is that I have a high predictability of like a rainstorm's going to come through when I run water around my pyramids.
Oh.
Yeah, it's kind of bizarre. I would say if it happens once or twice or 3 times, you're like, well, maybe this is a coincidence, but it keeps happening. So
Oh, you gotta gather some good data. Send it to us.
Yeah, I got to be more rigid about the data, and I'm kind of artsy, you know,
That's all right.
being an architect. So
You gotta become more rigorous.
yeah, more rigorous, log the data. I got to get, you know, some tri-field meters and better detection equipment and
Right.
oscillators,
All right, so what
oscilloscopes.
do you farm?
Uh, well, I came back home. My father got sick and passed away, and so I'm still here. And
Oh, I'm sorry
it's
to
kind of
hear.
a transitioning phase between, you know, the old ways of doing things with conventional farming and toxic ways of doing things on the planet. And so this farm's kind of been turned back into its natural state with prairie grass. And so I have cattle mostly as a stand-in buffalo, you know, so I don't have to get out the big mower shredder
Right.
and they take care of all the weeds and
Yeah.
the pasture maintenance, you know, and they
Yeah.
fertilize and spread seeds. And so
Yeah.
that kind of farming, you know, and you know, bale the prairie grass and sell that. And so just to keep things going so I could do
That's awesome. That's awesome.
so, but
Yeah.
I don't want to take too much time, but I'm excited that I got on here finally. So
I appreciate. That's great to see the inventions you've done and continue working on it, and then let us know what you find. There's some interesting things you're doing.
yeah,
It's
I've got
good.
water vortexes outside too with ponds, like little fish ponds, and
Uh-huh. Uh-huh. Okay.
um,
Yeah. And like,
observing what nature and plant growth and there's been all kinds of cool life that showed up with running water vortexes outside nonstop.
right.
So
Well, you know, that's the thing. It's like if you use the right elements with the right, you know, combination of size, like the right scale relationship and all this, you can entrain the structure of space to, and you get like really amazing effects because, and then you get insight in what was built before us, you know, all these pyramids around the world and this geometry and all this. It's really important. So, you know, you're discovering really important stuff. It's really impressive what you're doing over there. So you know, I encourage you to continue doing it and take good notes. Take good notes. Get a lab book, right? And write your observations.
okay.
Yeah. And stay in touch, Carlson.
Okay, I will. Thank you.
Yeah, send us your results.
I will.
Okay. Thank you so much. I appreciate meeting you.
Very cool. Thank you, Charlton, for sharing all that. So cool to see the resonance type technology being applied there. I'd love to see what he could do incorporating some art crystal technology into some of that. Could be pretty impactful.
Yeah.
Is there anything you'd like to say to finish the chat?
I was going to say to people, because, you know, first of all, thank you so much for your collaborations and contributions. And, you know, thank you so much for becoming member if you can, because it makes a huge difference for us to continue going and continuing to do the research. Let's get more people taking the course and getting on to these calls and, you know, discussing this stuff. It's so fun. And, you know, we're all learning together. I mean, look at this last example, this person in his basement, like running all kinds of cool experiments. And, you know, we're all learning, we're all growing together. And I want to give encouragement to people as well that what's going on in the world right now can be pretty discouraging. You know, we just moved to a new place, my family and my kids this morning, you know, we were just hanging out and and usually I don't have cable TV or anything. And in this new place there is that, and he turned it on and we were gonna go surf, but it wasn't so good. So we just hung there and we were listening to the morning news and it was just so disheartening, right? And it can be pretty discouraging. Kind of sent me on a tailspin this morning, you know, instead of my typical, you know, kind of focused morning, I had a little bit discouragement because when you see all this and you go, my God, what? But you know, we have to keep faith. We have to know that it's changing, and that while it's changing, it might be uncomfortable. It might be uncomfortable outside of us, might be uncomfortable inside of us. We might catch some, you know, virus or something. But we have to know that we have the power to overcome. We have what it takes to make it through, and we have the power to overcome. And we have to be the solid ones out there that encourages and support people and stay positive and stay keep our eyes on the 8 ball, keep our eyes on this possibility that's emerging for society, and know we're gonna make it. We are gonna change the way we do things. We're gonna change the way we produce energy, the way we transport each other, ourselves. We're gonna emerge into the galactic community. We're gonna make it. We just have to know, and we have to be solid inside ourselves. So I wanted to send so much love and appreciation to everybody that's participating, the 47,000 people taking the course, you know, in all the different countries, and as well letting people know we are here, we're working diligently. Please support us. Please help us get to our goals, and please contribute whatever you can, whether it's financially or just being part of the group and contributing your ideas and participating in those calls and all this. It all makes a huge difference. And until next time, may the vacuum be with you all. Thank you so much, everybody. Thank you, William. You're awesome.
Thank you.
Thank you, David. Thank you, Penny. Thank you, everybody out there for helping make these events occur. Much love to everybody. Aloha.